Please welcome to the stage Anyscale CEO Kirti Melkate and Anyscale co-founder Robert Nishihara.
Good morning. Welcome back to Ray Summit Day 2. Thank you so much for being here.
Yesterday, we got to hear from so many of you. We heard how Canva sped up training 25 times, how Reddit reduced the cost of online inference 10x, how Shopify is fine-tuning and deploying multimodal LLMs, and so many more. Yeah. And we're going to recap yesterday's keynote.
Yeah, let us quickly and very quickly recap yesterday's keynote about Ray and Anyscale. First, we outlined the complexity wall, the AI complexity wall that is so often the culprit for impeding progress at most companies that are trying to put AI into production.
And then we described the key piece of technology needed to actually break through this complexity wall. A software layer that can support any AI workload, that can support any data type or model architecture, that can support heterogeneous resources from CPUs to GPUs, that can fully utilize different hardware accelerators and really enable scaling from a single machine to thousands of GPUs, and do all of this while being able to really abstract away the complexity, the vast complexity of the underlying infrastructure from the end developer. And of course, that needs to fit into the overall AI ecosystem and really part of the unified AI ecosystem. So we're calling this software layer an AI compute engine. And the AI compute engine that we're talking about here today is, of course, Ray.
Ray has quickly become the AI compute engine of choice for the world's most experienced engineers who are trying to unlock AI at their companies.
Yeah. And so yesterday, we actually walked through a blueprint of this AI compute engine. We talked about the individual components and problems that this compute engine needs to solve, from compute resource management to data management to workload execution.
And we showed you what lives in Ray and what we've added in Anyscale, a supercharged version of Ray that we call Ray Turbo, along with powerful governance and developer tooling.
Yeah. And we shared a series of major Ray announcements, most notably compiled graphs. This is a new framework for direct GPU to GPU communication built into Ray that we think future-proofs Ray for our new GPU-centric world. We also announced the general availability of Ray Data. Ray Data is the world's most powerful processing engine for unstructured data, and major efforts on the stability front.
And on the Anyscale side, we announced Ray Turbo and walked through its dramatic impact on Ray speed and costs. And we also shared how Anyscale can advance your AI platform with our new provider for Kubernetes.
Yeah, and this is a really big deal. Right? Many of you here have standardized on Kubernetes, run on top of Kubernetes, and this brings Anyscale managed and optimized Ray clusters to wherever you run Kubernetes.
And we also announced Anyscale machine pools for your on-premises machines, and of course, Anyscale governance suite.
And we've made huge progress on the developer experience. We launched features ranging from automated dependency management to the auto selection of nodes, to the unified log viewer. And thanks to all of this work here, Goku is now on his honeymoon.
That's great. I'm happy to hear that. And it's a lot. It's amazing to see all of this landing.
Yeah. We also talked about you joining as CEO.
Indeed, we did. But much more importantly, it's about all of you, the community and the Anyscale team, bringing your energy in making this project from a brainchild to becoming the premier compute engine for the industry.
Yeah. And we talked about everything this community is doing, that all of you are doing, to truly bring AI to life. And I think that's it.
Pretty much.
All right. Well, thank you all so much. Thank you for being here with us this week. It's been so much fun.
Well, just like yesterday, you can find the Anyscale team at the Expo Hall. We are happy to take your questions and discuss your AI initiatives. Also, look out for a follow-up email from us about upcoming training offerings and Ray events at a location near you. Thank you again for the great energy that all of you brought yesterday. We're looking for more of that today and look forward to seeing you in the rest of the day. Thank you very much.
Thank you.
Next up, we have John Bicket, CTO and co-founder of Samsara. John and my association goes back 15 years from his time as he was developing his research at MIT, which turned into Meraki, a company that pioneered the idea of cloud-based networking. And we fought a number of years, hand-to-hand combat, trying to win business against each other in a lot of enterprise companies. Since then, John, after building Meraki into a multi-billion-dollar business, went on to start Samsara, which is transforming the world of physical operations with Ray, leveraging Ray for data processing, training, inference, and Ray is the AI compute engine at the core of their AI platform. Samsara is now multi-tens of billions of dollars in market cap and a very, very successful organization. And it is my great pleasure and privilege to welcome John to the stage.
Thanks for the intro, Kirti. And for folks that don't know, Kirti and I competed very intensely for the past 15 years when we were both working at companies in essentially very similar positions. So I was super excited recently to not have to compete with them and be able to partner with them. Super excited about that, and want to say both congratulations to him and the Anyscale team for their work. I want to tell you a little bit about Samsara. So we think about things a little bit differently at Samsara. We're really focused on transforming the world of physical operations. So when we look at pictures like the ones you'll see up here, we start to think about all the devices, all the equipment, and how we can really help lead digital transformations for these companies that are out making the world a better place. We're really focused on making them more safe, more efficient, and more sustainable. And these large, complex operations are super asset heavy and really labor intensive. So if you think about construction, there's yellow iron. If you think about field services, these are folks out doing things, helping to deliver goods, helping maintain our public infrastructure. We work with food and beverage distributors, transportation and logistics. These are really the companies that keep the world running. And every time we see a piece of equipment out there, we think about how can we help bring that equipment online. These physical operations are the backbone of the world economy. If we look at the companies that operate this type of infrastructure, they actually account for about 40% of the world's GDP. In the past 8 years, we've grown a tremendous amount by going and partnering with these companies, figuring out what problems they have to solve, how to help them monitor it, and then keep going from problem to problem, helping them to optimize their operations. We've ended up partnering across different verticals. We're working with 5 of the 10 top waste management companies, 6 of the 10 top construction companies, 5 of the 10 top transportation companies, and 5 of the 10 top chemical carriers in the US. Each one of these industries is really, really interesting, because if you start peeling back what they're doing, it feels like watching an episode of how it's built. Chemical carriers is a good example. At first glance, it might be a little bit hard to relate to like what they're doing, but if you've ever gone swimming in a public pool, you've actually experienced their product and how they deliver. They're the companies that deliver the chlorine that will show up at a school or a municipal pool and make sure that that's safe for you to enjoy. And in a similar way, a lot of the other companies, whether it's construction, are responsible for these huge infrastructure products that we're able to enjoy, even in a building like this, thinking back to what a massive project it must have been and taken years to complete something like this. So for my background, I was a technology person. I have a background in Wi-Fi. But when we started Meraki, we really wanted to partner with these companies and figure out what new technologies, since so much was changing across AI, across big data and everything else, what can we bring to them, and how can we start with working backwards from what they're trying to accomplish, look at what kind of technologies that we can identify, and then help to them to actually run a feedback loop. Very similar to how we ourselves as AI practitioners and things like this constantly have to go through and iterate, build our models out, work on iterating on the training setup. We kind of take a similar view in partnering with our customers, helping them get data about what's going out in the field, helping them analyze it, and then recommending things that they could do to make improvements in their operations. I want to give you a sense for the scale that we're able to operate at. So this is a snapshot of all of the vehicles that we're deployed on for our telematics solution. A snapshot of the roads that they drove in 1 hour, and you can obviously see this basically mirrors the physical infrastructure in the US that we end up being a part of and being able to observe every day. In the last year alone, we've had about 70 billion miles driven, and this has generated about 10 trillion data points that we've processed in our backend. And those data points might be things like GPS, it might be how fast the vehicle's going, it also might be things like a video clip of something that happened that we pulled off of one of our AI dash cams. And we take all of this information, aggregate it in dashboards that we have. We run AI models both at the edge on firmware devices, on hardware that we might deploy, and then also aggregate that information and make it easy to process so that folks can pull information from our systems and then put it into their own and make decisions based on that information. This is what our platform looks like. We have a bunch of different applications that we have. Usually our customers will deploy 2 to 3 of these in one go. Our biggest application is safety, so that's AI dash cams that sit in the cab and are able to process video, recognize safety events. We have a telematics solution, so this is doing things like running both more traditional algorithms to understand anomalies in data that we're pulling out from vehicles. It pulls things like fault codes from the onboard computer that a car has so that we can understand which vehicles might need maintenance and surface that information so that mechanics at these companies can be very targeted in the applications and the vehicles that they're going out and trying to surface in a way to really make it much more efficient for them. We also have a series of asset trackers that run and help understand utilization for our customers. We aggregate all this information together in our backend and then run AI models on top of it to help construct kind of a digital clone of that mirrors their physical infrastructure out in the field. So I want to give you an idea of what this might look like if you're a customer. If you walk through and you think through that you are responsible for managing a safety program for a company that has thousands of drivers, how is that going to work? Well, what you do is we work with them to get our telematics solution and our safety solution in their vehicles. We start pulling data from that, and then we aggregate it up, and create really simple dashboards that a safety manager at one of these companies could use so that they can manage a safety program with a very small team for a huge number of drivers. So you'll see in this, we've gone through, and this is a view that you might see if you were one of those managers. You log onto our dashboard system. You'll see kind of scorecards where we've gone through and tried to quantify exactly like how good and how safe some of the drivers are so that they don't have to go through, for instance, and retrain their entire fleet of drivers. They can focus on the spots that they need and be very targeted about where they're spending their time. So another view that they have, we make it super easy for people to coach. So what this might surface for an individual driver, if you're a safety manager, is clicking through and seeing where we've gone through and looked at all the driving time for a driver and filtered out the most relevant results for them, and then also gone through and recommended what types of trainings that they might need given those targeted interventions. So this makes it really easy for the safety managers to go through. They can, in about 5 minutes, go through and really intervene with certain drivers that they need, surface, understand what's going on, and then end up efficiently going through and improving safety. So this is one of our customers. I'm going to walk through this specific example. USIC, they are a leading provider of underground public utility locating services. So if you've ever been involved in a construction project or just even driven by one, you might see the signs that say call before you dig. And this is the company who will pick up the phone when you call. They send technicians out. They go out, they mark where the pipes might be so that if someone's doing construction, when they dig, they won't hit one of those pipes and cause a huge accident. What's interesting about USIC and a lot of these companies that are doing physical operations, if you go to their website, they have a couple tabs at the top. The first one is the services they provide, so you'll be able to read about the public utility locating services. But the second one up there is a whole tab dedicated and a whole web portion on their website dedicated to safety culture, because it's that important for them when they're talking both to the customers, their employees, and everyone else. They have a huge operation and a lot of processes around safety because their work is inherently pretty dangerous and risky. And if you aggregate any amount of risk over 12,000 technicians, there are a number of incidents that might happen every day. So they've gotten really good at managing safety and really driving down risk over a number of years as they've been operating this company. What we partnered with them for was to really focus on vehicle safety, because all these technicians have to drive to sites to do the work. And this was an area where they didn't have as much instrumentation and they didn't have as much visibility on what was going on. So they installed our AI dash cams and ran one of their video safety products there, and then instituted a driver safety program where they worked on scorecards for the drivers. They partnered with all the drivers to really decide how to drive down the number of accidents that they were having. And as a result of these processes, once we went through the trial, we did a bunch of measurements before and after they implemented our system and found that they were actually able to drive down seatbelt violations by about 85%. So results like these, when you aggregate them across thousands or tens of thousands of drivers, actually end up having a gigantic ROI for the company and making a material difference in their safety. It's pretty obvious like why everybody should wear seatbelts, but they take, if you have an incident and you're wearing a seatbelt versus not, it might turn a very severe accident into a very minor one. And if you aggregate this over thousands of driving hours, it makes an actual difference in the number of accidents that a larger fleet might see, and ends up having a material difference on the outcomes that they see every year. So we were super excited to see results like these, and these are pretty consistent when we end up partnering for safety programs. Now, there's a second thing which you might ask, like, I would assume AI models are pretty good about doing this, but one of the hardest things that we end up working on at Samsara is making these models very good. And we went through a period a couple years ago as we started to scale up with the number of customers that we were supporting and the number of applications that we were doing. As we were building out our AI team and really starting to scale, our infrastructure just wasn't scaling with us. And that's when we started to really partner with Anyscale, rework our architecture across the board to focus on how we could scale the number of models that we have, the number of applications that we're working on, and also the number of people working on the team so that we could do more for our customers. One of the biggest, hardest things about working with large enterprise customers is actually maintaining the quality bar in the models that we're rolling out and doing monitoring of them. And seatbelt usage, at first glance, we might think that it's something that models, are pretty good at and out of the box, but I wanted to share a couple of examples of what makes this particularly difficult and some of the tricky instances to work through. So this is one of them where I think, and I know everybody works through these when you're working on a new AI model. You want to understand the failure cases and go through. But for seatbelt cases, this is a pretty interesting one. You can see this person in this vehicle is clearly wearing a shoulder bag. So at first glance, you may be like, okay, well, yeah, he doesn't actually have a seatbelt on. And then you realize actually he does have this person does have a seatbelt on. And then at second glance, you realize that it's actually under his arm, if that makes sense. So it's not actually like properly in there. So this is a particularly tricky one that as we just kind of end up seeing across so many drivers, really interesting failure cases. I think this is another example of one of the cases in one of the cows that we see. So you'll notice a couple things in this image. The first one is that out in the real world, where people install the dash cams, it's actually quite complex. You can see that thing hanging over there. You can see the CB radio, if that makes sense, that was like hung up right here that the person was using to talk back with the dispatchers. It's not a seatbelt, obviously. And then you'll notice you can see it over here, and then on that side too, there is another seatbelt in there. The fascinating thing when we were looking at this data, he's not, it's buckled down through here, and you might be like, well, it kind of has a seatbelt on. The fascinating thing when we pulled up and we saw a cluster of these images start to show up in our data set, to generate our ground truth data, right, we end up looking at a bunch of different things. We label it, we look at the other sensor values coming out. We actually have the telematics unit in the vehicles there. We could read the seatbelt status out on that sensor there. Fascinating thing when we started to see these failure cases, we actually looked at the sensor on the vehicle, and they were telling us that the seatbelt was actually plugged in, if that makes sense. We couldn't figure out what was going on. We actually called out the customers and the dispatchers themselves and showed them this image, and we were like, can you help us work through what's going on? And they said, oh, I know exactly what's going on. They said, he opened up this person opened up the cab door, plugged in the seatbelt, and then sat on top of it, if that makes sense. And we were like, okay, that explains a lot. So it's kind of an interesting application where it's actually very tricky in some of these situations. And when you're running at scale, being able to go through and really understand the failure cases is absolutely essential because some of these cases end up really coming up and affecting product quality. So that was the seatbelt case. I think recently this year we've rolled out some new algorithms. We've been working on drowsiness detection, which is a new type of safety application that we're really excited about. This is a really interesting application because with the dash cam, it's a different type of classification. It's obviously looking at what's going on over time. And what we've ended up finding is that we're able to collect enough data off of the dash cams to actually feed it to the algorithms and let them take in a bunch of different signals. An AI dash cam looking at this the models can start to recognize if somebody's rubbing their eyes, yawning, heavy blinking. And what we've ended up seeing is that actually sometimes the models can actually be better than humans at detecting some of this. We've had this data rolled out with some of our larger enterprise customers so far, and I was just on the phone probably 2 weeks ago with a large oil field services company that was almost emotional about the impact that this had when they had rolled it out to their company. They said they were getting calls, and if you put yourselves in the shoes of the customer, this is a company that's delivering their folks are driving heavy machinery around. It's big trucks. it's big equipment, stuff that if they have an accident for it, it's very different than having an accident at low speed in a smaller vehicle. It's actually probably severe, and it may end up impacting other people. They had gone through they were having across several thousand drivers, about 2 to 3 incidences a day of drowsy driving that the operators, their dispatchers, were finding out about. So that means this wasn't the events that they had skipped over or that they didn't find out about that the driver was able to recover. It was like they either went off-road or had some other major incident that they were being externally notified about. Once they rolled out this detection, they were so excited in the first month of the trial, they said that they went to having, at the time I spoke on the phone with them, they had gone 32 days having 0 incidents of drowsy driving. So it's super cool to be able to see these, the algorithms and the impact that the AI work that we're doing and these techniques can have on people's lives. So we're using, I want to touch a little bit, we're using Ray across the board. Every time we talk about these models, we use Ray for orchestration. We use it for model training. We use it to sample events out in the field, pull them back, incorporate that into our training data set. And then we also use it for serving inference and serving up these models, running them both in the back end, and then we obviously run a lot of models over at the edge. But it's been really transformational for us to be able to operate these applications both at scale and across a large number of customers. So I'll stop there. We are really excited about these applications, and I think one interesting thing for us as we've been going through and partnering with these customers, physical operations hasn't been traditionally if we rewind 10 or 15 years ago, wasn't super technology heavy. But we have seen a real transformation as we've been partnering with these companies. There's kind of a newer generation that is operating these companies that grew up with a lot of the online tools that we've come to kind of expect in the software world. And they're asking questions like, what else can I do? What other AI models can I partner with you guys, or are you guys hearing about other cool technology? And I think there's a real opportunity here with how big this market is and how much of our lives that it touches to have a huge impact with the types of models that we've all been talking about and the new technology that's going on. We have a chunk of our team here, so I would love it, if you guys are interested in some of the applications or have ideas, please engage with them. And I just want to say thank you to the Anyscale team for the partnership over the last couple of years, and I'm really excited what we'll be able to do in the future.
Thank you so much. Thank you so much. No. Next, we have Stephen MacKinnon from Recursion. Recursion is at the forefront of all the trends we've been talking about here at this conference. They have massive data. It's unstructured data, multimodal data, and they're training huge models to apply to drug discovery. It's been a terrific experience partnering with Recursion. Please join me in welcoming Stephen.
All right, thank you. Really appreciate the opportunity to be here today and to tell our story of the innovative ways in which we're applying AI machine learning. It was really insightful to hear all the presenters speak today, to attend all the talks yesterday, to have conversations amongst all of you here, and to hear all of the impactful applications of AI, those really transformative ones, especially those that where AI is enabling processes that we weren't doing before. Those are really the ones that I find exciting and love being part of. In fact, I was out at dinner last night, and a few of the other fellow speakers and many of the other people that I've chatted with here today so far seem to have also started their AI journeys through the analysis of scientific data, through high-dimensional data sets in physics and chemistry, and life science. And I'm kind of curious here today, just by show of hands, how many people here have that background in scientific research? We got a few? All right. What about life science specifically? That's pretty good. There's a lot of people here that, that will get a lot of that deep content here as well. So, disclaimers aside, here's a secret. Here's a secret about drug discovery. In drug discovery, everything is a model. We talk about a cellular model, a disease model, a structure-activity model, an animal model. All of these are scientific models. The pharmacokinetic models that determine if a model will be sufficiently, if a molecule will be sufficiently distributed when absorbed by the body. The pharmacodynamic models to determine if the drug will deliver the therapeutic effect of interest. These are all scientific models, each one being a proxy built by expert scientists over decades that, when used correctly, will inform on that one ultimate grand experiment at the end of the tunnel, the clinical trial. And as time goes on, our industry has accrued more and more of these data points. Molecule by molecule, program by program, decade by decade, data sets turn into databases until eventually data scientists start analyzing the trends, finding patterns, performing searches, simulations, clustering, visualizations, until ultimately, in AI-based drug discovery, we model, ML, all the models scientific, right? We build machine learning models to represent all the experiments that we've collected and accrued. Each data set gets its very own model, models that must grow and be retrained and be versioned and be stored and accessed by many of the groups that are running different projects. This, of course, is why we need those modern AI stacks, right? With robust ML infrastructure practices, version controls, modern model serving capabilities. But again, now what, right? We could use these models to carve back on a proportion of the experiments that we might have otherwise run. We can enrich our programs for better outcomes, perhaps run more programs within those domains of applicability that we've set out for each of the models in the first place. But in a sense, we're not so much challenging how drug discovery happens, so much as we're augmenting or finding efficiencies. Moreover, if all of this data is really segmented across different companies, designed around their own core competencies and their own therapeutic areas. And really, this is the story of biotech. This has been the story of AI-based drug discovery so far. Finding all these scientific models, finding all these data sets, and developing machine learning models to represent them. I'm here today to tell a different story. Those applications that really excite me are the ones where you take different forms of data and you use them to transform and to create predictions for things that you weren't otherwise predicting before, right? Those in which you're using machine learning to enable new applications, to enable the types of insights that you weren't getting before, to redesign how data gets collected, what kind of data you can do, and how you can scale that data collection. So Recursion's story is that of scalable, high-dimensional data, robotic systems to industrialize data generation and data collection. Data, people, and compute. So rewinding a little bit, when we try to understand biology through the lens of an individual program, one at a time, through an individual target of interest, an individual pathway, we're casting this very narrow light on that landscape of opportunities. We're roughly charting out biology one pathway at a time, charting out the coast of an island in this complex biological landscape. We're also, and when we start programs with AI, we get drawn to these lights. We get, these are the lights, the beacons, where there is known biology that has been de-risked, that there is a lot of insight, that there is a lot of data. Things that have been seen and targeted by others, following in the footsteps of past explorers. But instead, as we're industrializing our experiments and our data collection, that landscape looks quite different, right? Rather than looking at everything on a case-by-case basis, we can take this bird's eye view of all the opportunities and can instead choose those opportunities that look the most promising, those that fall under new regions, creating medicines for populations with an unmet need. So just to make this a little bit more concrete, let's go through that first form of data collection. Let's start with cells. Specifically cell images. These are information-rich and inexpensive. These are the cornerstone example for the high-dimensional approaches for drug discovery data here at Recursion. All of these are microscope images of cells. So we got two different systems. On the upper left side, we see, of each system, we see a disease state of a cell. On the upper right side, we see the control, how the cell should look in a healthy state. And the goal here, and the overarching goal of drug discovery, is to find a new compound, a new medicine, that when you start dosing the cells, when you start dosing people, at increasing concentrations, you start seeing that disease state get restored and start seeing these look healthier and healthier, right? And the main point here is that these images are this information-rich and inexpensive to generate. And they're scalable, right? In fact, we run these experiments on full plates with 1536 wells, where each well is one experiment. We add cells into the well, and we perturb those wells in different ways. We add compounds to those wells. We knock out or we remove genes from the cells one by one across different wells. Each one representing modeling a different disease or a different treatment. So this is not unlike the microscopy images that the oncologists, the pathologists, and the research scientists do in the lab. That they use to diagnose conditions or suggest therapies. But unfortunately, we can't scale those oncologists. We need a better way to read those images. Instead, our images are analyzed by masked autoencoders, a self-supervised approach to machine learning in which the goal for our models here is to do image reconstruction. So we train masked autoencoders on this image reconstruction task such that they can reliably reconstruct images starting with only a randomized 25% subset of the initial image. We've also shown that it scales with the architecture and the amount of data on hand. Last June, we recently upgraded our on-prem supercluster with over 500 NVIDIA H100s and quickly wanted to test out these new GPUs. So the first thing that we did is we increased the size of these models. Our original version of this masked autoencoder had 300 million parameter model. We upgraded it to a 1.8 billion parameter model. But rewinding there for a second, why would we do that? Why would we do, the goal here isn't to generate images of cells, right? Why do we get that question quite a bit. Rather, if the model is able to reconstruct the original image, it's able to interpret what's happening inside the cell, right? To notice those morphological abnormalities, to notice when something is elongated or a part of the cell is larger than it should be or smaller than it should be. Those intermediate layers between the encoder and the decoder actually carry a lot of that really meaningful information that could be used for downstream tasks. These can be used to determine if images are similar to one another or different from one another and how they differ in which ways. You could tell if a cell perturbed by a compound or had its gene removed are sufficiently different from our controlled or our unperturbed cells. And what we found is that our new 1.8 billion parameter model is now able to detect 20 to 25% more of the genes that we expected to see based off of our benchmarking data sets. And this opportunity space is huge, right? 25% of the genes is more things that, more regions of biology that we can now see. It's it's a bigger light that we can kind of cast on that map. And more therapeutic opportunities, more medicines we can discover. But there's also a problem. To date, we've run over 180 million experiments. Since the last time we did this exercise of upgrading our models, we've steadily increased the number of plates that we've analyzed, maybe doubled the amount of data that we had. We've scaled up our model by 6-fold, right? all of these homegrown systems that we had to run inference on it, they were starting to reach their limits. We couldn't necessarily get the observability on it. It would take months for us to run these on. And that's really where our journey with Anyscale comes in. So we're pretty new to the Anyscale family. We've been part of our tech stack now for about 3 months. And we, like last week, the last couple of weeks, we really put that here to the test, right? So we called up our cloud compute provider, asked them for 4,500 GPUs. This was a new model architecture and a new GPU type that we hadn't dealt with before. And we wanted that data. We wanted that data fast. So this was kind of our first real application of that Anyscale system. We were able to get that going. Very few issues. Got all the images inferenced in a day. And one of the really meaningful things here is that we didn't have to spend as much of the time figuring out that inference stuff, figuring out the compute and figuring out how we would distribute all of that data. Instead, our data scientists are able to spend their time asking, how do we properly align these embeddings? How do we aggregate them? And how do we transform them into useful representations of biology? So these embeddings allow us to relate experiments. That's really the value of the machine learning, of the AI in this case. It's what allows us to compare these images. So here in this plot, every dot that you see is a different gene that's been removed from the cell, and how similar those cells are to one another with that gene removed, right? So it's colored by different groups of genes that when removed give a very similar effect on the cell, and that means they're related functionally. It means that when the cell functions, the molecular pathways that gene is involved with are impacted in the same way. And these embeddings also allow us to project all of the compounds that we have in our library. Right? We've got these corresponding experiments where instead of perturbing the cells with gene knockouts, we perturb them with compounds. And we can see that the embeddings for those compounds look very similar to certain genes, implying that they mimic those genes, that they impact the same areas of biology as those genes. And really, this is the landscape from which we can mine those new opportunities, that we can kickstart new programs. So stated a little bit differently in tech bio, right? Where we discover models of biology. And in this context, we're no longer talking about models of models, we're talking about new models, right? Like we're intertwining kind of the concept of the data with the concept of the machine learning. Data that standing alone isn't as useful, and vice versa with the machine learning, right? Machine learning is what's providing us with that relatable representation across the different facets of drug discovery. It's what allows us to build new scientific models as well as ML models by revisiting the nature of the problem itself. So connecting across these layers is what allows us to fuse the strengths and limitations of each of these modalities, to couple the scalable representations, like the cell images and the phenomics, which those that instead provide more detail, that might not be as scalable, to tell us which routes to pursue and which ones lead to dead ends. So to recap on our phenomics, these are our cell models. We continue to scale and push the dimensionality on multiple fronts, adding more compute and innovating on the assay itself. What you see here is actually the next version of the assay, where instead of staining, like fixing the cells to the plate and staining them so that we can really examine, so that the experts can look at the cells and see what's happening in the various subcellular localizations. Instead, it's bright field imaging. And these are, while they're less interpretable to humans, the AI models extract just about as much information from these images as they did with the stained images. And that provides an opportunity, an operational advantage in the lab for them to create even more plates. The other opportunity that it provides is because we're no longer fixing these to the wells, we can take snapshots at different points in time, and we can start adding another dimension to the problem, time. All right? So the really interesting thing here is that we're starting to trade off human readable representations for those and start optimizing them for the AI instead. So another data layer here is the transcriptomics, right? This is where we do gene sequencing, specifically in the very same context as the cells in terms of removing genes or adding compounds. We do the same thing, but instead of taking photos of the cells, we sequence their transcripts. We can tell which genes get upregulated or downregulated in response to that compound, in response for that gene knockout. We can also do this at scale. Now, not the same scale as the hundreds of millions of experiments that we do with the phenomics, but still a substantial scale nonetheless, 1 million samples sequenced so far. Each of these samples with thousands of genes themselves, right? If I were to rewind 20 years ago, I spent a summer in a research lab, and I spent 4 months sequencing one gene. One gene. This is literally billions of times larger than that. Another data layer as well is we automate our ADME data collection. That is the set of experiments conducted to profile if a compound will be properly absorbed and metabolized in patients. These, of course, are supported by large chemistry models that excel at representing small molecule drugs. These robotic systems are able to profile about 750 compounds a week, and by using our models, like at this scale, even though it's significantly larger than what we can see in more traditional labs, it still doesn't reach the millions of compounds that we have access to, or the infinite or near infinite amount of compounds that we can design, right? So it's important for us to have these models to be able to see which direction we should be going. So every time we run one of these experiments, every week, when we get 750 new compounds in, we automate that model rebuilding and deployment process. And that was another system that we developed through the use of Anyscale over the last few months. And this is what allows us to record 750 molecule data points, but have that be applicable to thousands of molecules instead. Lastly, at the animal levels as well, here AI helps us detect and monitor mice in our digital vivariums. So these cages are designed to continuously monitor mice as our ML models determine if there are changes in their eating or sleeping or behavior patterns to see if they're getting drowsy, right? As the mice are exposed to these new compounds, it's what allows us to front load safety in our programs. Lastly, we also develop LLMs to interrogate the data and to launch new analyses, to run models as well, right? But one of the key pieces here to highlight is that our model serving needs are getting much more complex. Our model systems are now starting to interact with one another. Our research labs at Valence are pushing the boundaries of generative design and multimodal systems, each with complex architectures requiring rapid inference and model-to-model interactions. So, and really, as we see more and more predictive models in complex ML systems, we're making this choice now to invest in that solid stack of ML infrastructure to accelerate development and enable future applications. And ultimately for what? Industrialization, the use of AI is what allows us to explore a much broader landscape of therapeutic opportunities, triaging those that will drive the largest impacts and address unmet needs. It front loads failure, as well as driving down the costs and the timelines. So the take home here is that really for us, AI is the means by which we consume the data. It's the unlock that lets us design scalable, high-dimension experiments that serve multiple purposes. We don't necessarily conduct an experiment at the time that the program is generated. We pre-run a bunch of experiments in order to identify what that landscape of opportunities looks like. It allows us to be more selective and more intentional with the opportunities that we act on. It allows us to simultaneously reimagine and intertwine both the scientific and ML concepts of what a model is, and what model should be guiding the future of drug discovery. Again, really appreciate the opportunity to speak here today, and I'm around all day for questions. Thanks.
Thank you so much. It's incredible work. Thank you so much, Stephen. AI is going to transform medicine and biology, and Recursion is really leading the charge here in bringing that about. Next, it's my great pleasure to introduce Brandon Leonardo. Brandon co-founded Instacart, the world's largest grocery delivery company. He now leads Instacart's generative AI efforts and is working to create a world where everyone has access to the food they love and more time to enjoy it together. Please welcome Brandon.
Hi, everyone. That last talk was really cool, and we're not going to talk about biology or anything so cool, but hopefully you can empathize with my talk a little bit at least, which is a question that we ask ourselves all the time. Instacart's core customer is families, and one of the things we joke about, the most universal question that every family has is, what's for dinner? And it's like 11 a.m. right now, so you probably haven't asked yet, but I bet by the time 4 o'clock rolls around, you're asking yourself, like, what's for dinner? And there's a lot of mental labor in that. There's how much of my budget do I have left this week? Do I have a sick child at home? Do I have a special occasion? Am I trying to eat healthier, right? There's like a lot of work that goes into that. And we think that generative AI provides a way for us to help answer that question for our customers. This is the core problem that we're trying to solve for our customers. And for 12 years, we've been doing the physical labor of groceries. You give us a list of ingredients. We show up at your house an hour later with them. It's magic. But we think that we can do more, and generative AI gives us that opportunity to do that. So I wanted to talk a little bit today about how we're using that in our current customer experience, the second part of our strategy around internal productivity, and really briefly on some things that we think are possible future experiences that we can create for customers. So we started a year and a half ago, the same place that everyone else did, right? We built a chatbot, and we wanted to answer really meaty questions for people like, what's for dinner? What should I eat? What meal plan can I have? And we were building this chatbot. We had it in kind of a beta for our internal employees, and on a Friday evening, we accidentally turned it live for a bunch of our customers in July of last year. So we woke up on Saturday, and all of a sudden, there's conversation data streaming in that we did not expect. And we're like, oops, but hey, this is great. We're going to get feedback from customers, and we're going to see what use cases we can solve for them and where they're using this. And again, we'd hoped that they would be asking questions like, how can I do meal planning? How can I eat healthier? What they actually asked was like customer support questions. It was like the vast majority was, I need to edit my order, or I need to reschedule, or things like that. And so we said, okay, well, we're going to listen to our customers, and we retooled the whole product, the chatbot. We turned it into a customer support chat, which is really obvious. That's not like, it's so obvious, it's not what we wanted to do, but it's what our customers were asking for. And so we moved it into the customer support side, and we launched it. But we kept paying attention to what customers were asking. And the vast majority of the things that they were asking for help for were things that they could do themselves. This was stuff that was in the UI, right? If you want to cancel an order, edit an order, reschedule, add items, you can do all this yourself. But they couldn't figure out how to do it, or our product wasn't simple enough. For whatever reason, we thought, okay, well, there's some mental labor that we can try and help for customers. So we built something called Action Graph, where our CareBot not only knows the answer to questions that you're going to ask, but it has access to the actions that we can perform on your behalf. And so when a customer comes to the CareBot and they said, hey, I need help rescheduling my order, we don't tell them where to go in the app to do it. We just say, when do you want to get your order delivered? And we update it for them. And I think that this is something that customers are going to start to expect, right? I think in the future, we're going to see companies are going to have an agent, customers are going to expect to interact with that, and that agent can do things on their behalf. The other place we're using generative AI is in search. So we've done a great job of answering the question like, if you need bread or milk or eggs, we give you a personalized set of responses. We try to get you what you're looking for. But what about things like, I have soccer game on Saturday for my kids, and I need to provide snacks for 25-year-olds. Like, what do I do? We weren't good at that. And now we were actually able to put generative AI into the search bar. So when you ask us those really complicated questions, we can turn around and give you an answer. And the thing that's been interesting here is like the answer wasn't build a chatbot and put it in the product. The answer was like meet the customer where they are and just put the generative AI kind of into the thing they're already using. And so now we have a place where we can take that mental load off of customers and help them answer those difficult questions if they want to ask. The third place that we're using generative AI, and this is not flashy, right? This is the catalog at Instacart. We have one of the biggest food catalogs in the world. We have 85,000 stores. We have billions and billions of items. When we started Instacart, that catalog didn't exist. And the way that you went and got that catalog is you went to the store and you bought one of every single item and you took it back to your office and you took a picture of it and then you sent that picture off to get edited and then you sent that picture to other humans to go extract attributes and then you put it on the site. And we've done this for millions of items at this point. It's a massive amount of work, massive amount of expense to do that. The catalog is kind of the unsung hero of Instacart. No one thinks about it, right? But it's 90% of the pixels that are on your screen. If you're lucky, you can sometimes get the manufacturers to help provide data or the retailers. But extracting all of that information, there's not a lot of depth to it, right? We're able to do now is use LLMs. They're sort of like a missing magical box in the middle that takes all of this catalog information and extracts attributes. We've had massive impact from extracting things like wine tasting notes or wine pairings or like claims, like does this product claim to be organic? It's not showy, it's not flashy, it's not like the thing you write blog posts about, but it's having a massive impact for our customers. It's increasing sales of wine, for instance, or organic products, helping customers find those attributes. And this is an area where we've actually partnered with Anyscale. So they're powering the infrastructure with the batch vLLM that is extracting all of these attributes from all these billions of catalogs. And the thing that's really amazing about it is the quality is as good or better than anything else we're doing out there. The results are returning faster, and it's like 10 times cheaper than anything else out there. It's like the last time that was happening when I was a kid and CPUs were getting like better, faster, cheaper. It's just amazing the way things are working, and we're really happy to be partnering with Anyscale to do that. The second part of our strategy at Instacart was really tooled around internal productivity. And so we thought, well, if we can reduce the mental load for our customers, maybe we should try to do that for our team members as well. And this has been something, there's been some interesting like downstream effects from that, which we'll talk about. But we had to have a top-down push. It's hard to change culture. So our CEO kind of came out with a top-down mandate that everyone needs to figure out how to use AI and adopt those toolings to be more effective, to do a better job, be more productive at their jobs across the entire company, across the entire every function. So changing how 3,000 people do their jobs is not easy. It took a lot of effort. Some people are immediately concerned about the long-term impacts of their job. Some people are just really busy. They don't want to learn a new tool. Like getting developers to switch from VS Code to another version of VS Code is really hard. Some people don't know like how to use the tool. And so we had to do a lot to democratize the use of AI. So we created some tooling internally. This is something called Ava that is our own version, internal ChatGPT client. And we're able to enable this for everyone. But the nice thing, it's got all the privacy concerns like taken care of for employees. You don't have to worry about where am I putting my code or where am I putting my work product. We also have a prompt library in there. So if you don't know where to start, you can do a kind of a one-click get started and help me summarize or help me write an email. And then it also has access to all of the most recent models, so GPT-4 and Sonnet 3.5. And so employees are able to play with these different things and figure out what's going to work really well for them. We also built Ava right into Slack. So meeting employees kind of where they are. Ava can also sit in on your Google Meets and transcribe the meetings and summarize the action items and the summaries and provide that to all the attendees of the meeting. It's actually really cool because think maybe we can get to the point where you don't even know to go to the meeting anymore. But we also had to do a lot of internal training. So we created something called AI Empowered, which is an internal Slack room where employees were able to share things that they were doing to be more effective at their jobs, or ways to use AI to give inspiration for others. And so you started to see, as folks shared, other people and other functions would start to adopt these things. We also created learning content that explained, what is generative AI in the first place, like what are some ways you can use it. And again, it's hard to get a bunch of people to do any one thing, but we started to see this actually pay off. And so now we're at the point where the vast majority of the company is using Ava every single week, and that's not even including Copilot or any of these other AI tools that folks are using. And there's been some really interesting downstream effects from this. Everything I talked about earlier, like with Ask Instacart, chatbot, those were built by teams that were sort of focused very heavily on AI. What we started to see is when you have employees using AI as part of their daily workflows, they're going to find ways to use AI in the product. And so we've seen it just spread across the company. So now we have shopper teams, customer teams, enterprise teams. Like, these things that we were pushing for are now spreading naturally because people are a lot more comfortable with it. They're figuring out how to make it, how to reduce that mental load for themselves, and then how to do that in turn for customers. It's had a couple other interesting effects. So you have to start to make it easy for people to do the right thing. Back to our catalog augmentation example, we have billions of items, right? And it would be really easy for an engineer to grab an API key from an AI provider and kind of set up a job over the weekend to iterate and enumerate through each of those billion products one by one, making calls to the LLM. And you can sort of do the math on what that would cost. I know exactly how much it costs. When what they should be doing is using our batch LLM processing. But you have to start to think about how do you make it easier to do the right thing? How do you remove that mental load? Another example that we have, so we were doing these small group trainings. We would take our most avid users of Ava across the company and give them access to things like our AI gateway, superblocks, tools that they could solve some of their own problems. The person in finance, part of their job is to analyze all of our experiments and analyze their impact to profitability, right? It's something that takes hours or even days a week. It's a very manual process. And so he grabbed, AI Gateway and threw a script together. It's literally never coded in their life. And he automated that entire part of his job. So now, instead of spending hours gathering all this mental data, clicking between screens and copying them into a spreadsheet, it just dumps it in a spreadsheet and he goes, and it's more of like a spot check now. The thing that's interesting about this, though, is like, that's awesome, right? I love that he's spending time doing more strategic things for the company. But also, when we built the AI Gateway, we built it for machine learning engineers, right? Like, the people that are actually using it are machine learning engineers, software engineers, product managers, designers, 30 people from accounting, right? Like, there's all these people that have started to adopt this tooling. You need to make it easier, and like, the customer that you're serving has changed. You guys are the builders of the AI infrastructure and the AI tooling here, right? This is, I think, really important. It's something that we've started to invest a lot more heavily in, making things available to a broader customer base. So the last thing I'll leave you with is just a preview of some things we're thinking about with generative AI. I'm not going to say that I know where the future's headed. I think it's changing so fast. There's no way to know. But you can sort of look at the past and think about what are things that I personally want. We're working on something called the personalized planogram. And we've got a decade of history in the grocery space, and the more we know about a customer, what they like, their preferences, the better job we do at personalization. The concept of a personalized planogram, so actually a planogram, for those of you who don't know, is a term that's actually rooted in a physical retail space. So when you walk into a grocery store, there's a map, and it's, the planogram is what says that the produce is going to be over here, the milk's going to be over here, the chips are on this aisle, and this set of chips is there, and this set of chips is on this second shelf, and it's lays out what that store looks like. And retailers build this, they put a lot of effort. This is a special sauce for retailers. But when you go into that store, you're in their planogram, right? A personal example that I have is I spend a lot of time looking at nutrition labels. I have a 3-year-old, I want to make sure that he's eating healthy. I don't eat certain ingredients. I do a lot of mental math to like figure out what's the calories over grams of protein. Is this a product that I want to consume? When I go into the store, I have to like look at the labels and I have to walk around and find the things I'm looking for. I think that that's going to change. I think we're going to be able to build an experience that's really, truly customized to you. And I don't mean like personalized in the way we think about it now, where 10 years ago, Instacart like looked the same for everyone, right? Today, if you go to Instacart, it's highly personalized to what we know about your preferences, the types of things that you're buying. But the boxes, we're personalizing the content in the boxes, right? The boxes are still the same. I think in the future, we're going to, well, I'm hoping to see that the actual experience, the user interface, starts to be personalized to you. So my version of Instacart may not be what your version of Instacart looks like, but it's going to be very personalized and it's going to be exactly what you're looking for. And it might even change depending if you're doing your weekly shop or if you're just getting a couple of extra ingredients for dinner tonight, or if you're shopping for like a barbecue, a special event on a Saturday. So I'm really excited about that. It's something we're still playing with. You'll start to see these things roll out over the next few months, but I think customers are going to start to expect a lot more personalization, a lot more personalization in interfaces over time. So if there's anything I'd leave you with, I think you all know this, but you got to remember to solve the core problem for your customers. You can't just use AI and bolt things onto it. You need to really make sure that you're doing it using generative AI in a way that's going to solve that core problem, and it's not always flashy. In the catalog example, but it's one of the most effective ways. Investing in productivity across your company has been one of the fastest ways that we found to increase adoption through the product and R&D teams as well, and I think that's probably true. And then finally, the downstream effect of that is you're going to have to take your tooling a step further than you probably normally do and really make it usable by your whole team. Because if you're doing this right, that's who's going to be using it. So thank you.
Thank you so much. Let me get the clicker, please. All right. Brandon, thank you so much. It's really inspiring to see how much the Instacart team is shipping. So next, it's my great pleasure to introduce Kevin Weil. Kevin is the Chief Product Officer at OpenAI. He previously led product for Twitter and Instagram. He co-founded the Libra cryptocurrency at Facebook, and he was president at Planet Labs. We're very, very lucky to be hearing from him today. Please join me in welcoming Kevin. Kevin, thank you so much for joining us.
Yeah, thank you for having me.
So, you previously led product management at a wide range of companies. How is product management different at OpenAI?
Very. It's, to some extent, product is different at different companies. A lot depends on the founder and the culture of the company. Twitter was probably too much of a consensus culture, and so we could have moved faster. Instagram, you had Kevin Systrom, who's one of the best product thinkers, I think, in the world. At OpenAI, obviously, Sam is a visionary and pushes us to think big, but also leaves room for us to kind of figure out what we need to build the right things. But really the biggest difference is in every place that I've ever worked before, you kind of have a fixed technology floor, and you're trying to figure out how you use that to build the best product you can. You're trying to understand your users, what their problems are, but you kind of know what you're working with from a technology perspective. At OpenAI and with the AI ecosystem in general, the technology floor is not fixed. Like every month or two, computers can do something that computers have never been able to do in the history of the world. And you also can't quite see it coming. Sometimes you have a sense that there's going to be this new capability in the next model. You can kind of see it coming through the mist, as it were. But you often don't know until the model's really baked. Is it 80% good at that thing? Is it 95% good at that thing? Is it 99% good at that thing? And the way that you build a product for an 80% correct thing versus a 99%, super different. And so, a lot of this is we're figuring out on the fly and the world is changing, the technology is changing so quickly. It's a huge challenge, but it's a fun one.
Yeah. So. Not just for you guys, but also for your customers, right?
Yeah.
For developers building on top of your platform.
Yeah, I mean, I was in a meeting with one of our enterprise customers recently, and they asked if they could have they're like, we would love, this is all great, we're happy, but could you give us a 60-day notice of all the things that you're shipping? Because it'll really help us. And I was like, I also would like a 60-day notice of all the things. So
that's a good point. Yeah, I mean, you mentioned enterprise customers. So you guys serve both consumers with ChatGPT, right, as well as developers with your API, right? And since this is a developer audience, let's talk a little bit about the developer side of that equation. Can you share a little bit about the strategy for your developer-facing roadmap?
Yeah, and we just had our dev day yesterday, which was super exciting. It had a lot of big releases. In general, the philosophy is more AI is better for the world. So the more that we can get AI in the hands of developers who are going to do amazing things with it, the better. And so we try and put all of our frontier models into the API. We try and bring new capabilities, with multimodal capabilities. Like yesterday, we just launched the real-time voice API.
Congratulations, by the way.
Thank you. Thank you. We're super excited about it. I mean, we launched distillation yesterday, so you can distill bigger models into smaller models that are very good at doing specific tasks, doing it cheaper. Like in general, we want to bring more intelligence. We want to make it cheaper. We want to make it faster. We want to make it safer. And we want to give it to the 3 million plus developers who are using OpenAI through our platform, because you all are going to help bring more AI to the world, and that's going to be a fundamentally good thing for people around the world.
Were any of those launches the most exciting for you?
I think distillation is going to be a fundamentally important one, because it will just enable more uses of AI. It's kind of amazing how, the trends in this space are wild, right? I think if you go back to the initial API launch, GPT-3, I think, and then you compare today, GPT-4o mini, so one of the most capable models we have, is I think it's 1% the cost of what GPT-3 was when it launched. So it's massively smarter, it's massively safer, and in 2 years, less than 2 years, it's come down by 99% on cost. I don't know if there are many industries like that, but it's fantastic, because the more that you get, the more AI becomes available, and the cheaper it becomes, the more use cases you can apply it to, the more problems we can all solve together. So, we're just trying to put it in the hands of more people. So I think distillation's a big one. The advanced voice mode is just, I could talk about use cases for that all day long.
I just want to echo your point here that we've seen with Ray, every time you can make something an order of magnitude faster or cheaper, you're going to unlock way more use cases.
Yeah. Yeah, I was in Seoul and Tokyo a few weeks ago, and was in a bunch of meetings with customers over there. We had translators for a bunch of the meetings, but then you'd have places where you were just kind of milling around afterwards, looking to talk with people. And there were a number of folks with whom I don't speak Korean or Japanese, and they didn't speak English. We had no common language. So I took out ChatGPT and I said, hey, ChatGPT, I want you to be a translator for me. When you hear me speak English, I want you to say it in Korean. When you hear Korean, I want you to say it in English. This is using our new advanced voice mode. If you have Plus, you can use it today. And it did it. And I was able to have a conversation with someone. We wouldn't have been able to say 2 words to each other, let alone have a full business conversation. And that was profound. But you think about other use cases of that. It's not just about business. Think about travel and tourism and what might change if people aren't afraid of going places where they don't have any of the language. It's like ideas like the universal translator.
That's been around for a long time, right?
It used to be like, Star Trek, right? It used to be science fiction, and now you've got one of these things in your pocket. It's
I
just
remember seeing some
amazing.
demos of this maybe like in 2015 or a little while back.
Yeah.
But that is truly incredible. Let's talk a little bit about the competitive landscape. What do open source models mean for OpenAI's business?
I'm glad they're open source models. I think they, I think it isn't an either or. It's, again, about, from a philosophical sort of mission perspective, it's about getting more AI into the hands of more people, and I think that's great. I also, worked closely with Mark for a number of years. I have a ton of respect for him. It's a super smart strategy for Meta. So, we do a little bit of open source. We have our Whisper models, which do transcription, which are totally open source and have been
just
for
released
a while.
Whisper models, right?
Yeah.
That's awesome.
So, I think it's great. We get more AI in the hands of more people, and ultimately what people want is they're going to try and find the most capable models for the best price that, also are as safe as possible. And more choice is a good thing.
If you think about the gap between the quality of OpenAI's best models and the best open source models, do you expect that gap to grow or shrink, or is it,
I mean, we're certainly going to do our best to make it grow.
Yeah. How do you think about competing with the cloud providers? They have the resources and data to build great models.
Mm-hmm. Yeah, they're all very different, right? In some sense, like a lot of competition is inevitable because this is maybe the fastest growing market the world has ever seen. You got to kind of take the cloud providers separately, I think. Microsoft is a deep partner of ours, and when they're doing interesting things with models, it's usually through our models. Google is more of a direct competitor, and then Amazon is like, the kind of Anthropic. They're kind of playing the field and building a platform with Bedrock. But again, more competition, more choice. Like, competition makes us all better. You all are going to get better AI models because there's a huge amount of competition in this space. And that's good for the world. And it's up to us to do things that some of those big cloud providers can't. It's up to us to move faster, to take some more risks on the product and on sort of leaning into the capabilities of these new models. And that's what we're going to do.
Yeah. I was really impressed with the release of O1, the reasoning model.
Yeah.
Can you share anything about just challenges with turning that model into a product?
Naming? Who's played with O1, just out of curiosity?
Wow.
Awesome.
Okay, almost everyone.
So one of the interesting things with O1, there were a bunch of interesting challenges. One of them was, so O1 is, for those who haven't played with it yet, you think of the normal kind of model building paradigm that we've been in, where you go, from the OpenAI one, GPT-2, 3, 4, 5 in the future, et cetera. They just get, you're putting more compute onto a bigger pre-training data set. You're doing this massive pre-training run. And the model is sort of very broad and has accumulated a lot of facts and knowledge. But it's still kind of system one thinking, right? You ask it a question, you get an answer. The difference with O1 is it actually, if you'll allow me to anthropomorphize a little bit, it's learned to reason. So when presented with a question, it doesn't just spout out an answer. It thinks. It develops hypotheses. And then it will test those hypotheses against what it knows and will affirm those hypotheses or refute them, and then use that to develop new hypotheses. It's really, if I gave you a hard question, you would think about it for a little while, and in your head you'd be developing hypotheses. Well, it might look like this. Well, no, actually it doesn't that. And it's kind of doing that behind the scenes. And so it's actually able to push the frontiers of knowledge. It's not just about what it's learned. It can reason and get to new places, and it's fundamentally different. So it's not just about doing a bigger pre-training run. You're actually applying more inference at at question time, and that's a fundamentally different way to scale a model. And it's really good at things like science and reason and mathematics that are sort of pure reason. One of the things that we didn't know was how kind of generally valuable was it going to be? We knew that at things like, again, like mathematics and science, it's off the charts. If you use evals like benchmarks like GPQA, which are like hard graduate level science evals that you can't just look up an answer to on the internet, it's better than 90% of all grad students across every scientific field at once, which is like leaps and bounds better than 4.0. But how relevant would that be for coding or for creative writing, for things like that people were using ChatGPT for? So would it be valuable to a niche, or would it be really valuable broadly? And what did that mean for how we built the product? Also, it needs time to think. And so, I mean, it really is in the background doing a bunch of thinking. So what's the right way to represent that? And we ended up representing, we ended up sort of giving you, if you've used it, it gives you a summary of how it's thinking as it goes along. And then we'll give you the answer, which is also interesting because it lets you see a little bit about how it derived its answer. But like tons of new questions and challenges as we were building it along the way. The good news is the reception has been great. We made it available in the API, which is something we were super excited about because we knew that developers were going to have some of the hardest, most challenging use cases of all. And I mean, I can talk about some of them, but we've really seen great uptake and also just some inspiring things that O1 can do.
Yeah. Actually, just going off of what you said about how broadly applicable it is, it's clear to me that some of the hardest science research tasks, maybe curing cancer, will require models that have tremendous reasoning capabilities. I think they're on the other end of the spectrum. There are tasks, maybe summarizing a news article, that don't require as much reasoning. Where are most tasks going to fall in that spectrum, if you fast forward to the future?
Yeah, I mean, it's interesting. If you think about some of the most economically valuable tasks, if you will, today O1 is sort of context window limited at the end of the day, and we'll improve that, and it'll have longer context windows. It'll be able to think more. So today it thinks, for 60 to 90 seconds. It's kind of funny. Sometimes I think I ask it a hard question, and it thinks for 5 seconds and gives me an answer, and I'm like, oh, I wasn't able to challenge it. But it'll kind of top out at 60 or 90 seconds. You could imagine a world where you ask it a hard question about how you cure some particular form of cancer, and you let it think for 5 hours, 5 days, 5 months. And so there are certain questions, I think, that will be where you'll want just like massive amounts of thinking time. And then the questions around like, hey, summarize this email for me. I think one of the things that's going to change is we're used to a model where the AIs are, I mean, they're pretty smart. We take for granted, you very quickly like update your firmware with how quickly something gets good. I was reading some article about somebody who was trying Waymo for the first time, and they said 10 seconds in, they were like, oh my God, watch out, there's a bicyclist over there, is it gonna, and then 10 minutes in, they were like, oh my God, this is the coolest thing ever. And then 20 minutes in, they were bored and just checking their email on their phone. Like how quickly we update to like amazing new technologies in the world.
Actually, for people who are traveling in from out of town, before you leave San Francisco, you should try some self-driving cars.
You definitely should. It's magical. But we're still used to this world where we kind of have to like instruct the AI on a very individual basis. Like, here's an email. I want you to summarize the email for me, and then I will take the email and do something else with it. I think we're going to move from a world of the AI answering questions for you to a world where the AI is actually doing things for you in the real world and accomplishing tasks for you that are not 5-minute tasks, but are 5-hour or 5-day tasks. And even, I think, mundane things, business, workflow, efficiency kind of things, take a bunch of reasoning in that world to put a more complex plan together and then act on it and periodically check back in with you. So I actually think O1 and just reasoning in general is going to be a much bigger part of the future.
Yeah. So does that mean that every developer building on top of this model is going to have to kind of rethink the UX of the product they're building to take account for these increased capabilities, but also significant delays?
Well, I think it's almost more of a fundamental philosophical shift where you're used to this, again, this sort of system 1 level thinking with AI where you can ask it a question and get an answer. You're going to be able to ask the AI to do things for you. It's going to be much more agentic in the future. And it's a different way of building products, I think, at that point. So yes, for sure, things like UIs will change because things will need to be more async. But actually, it's just like products that weren't possible before will become possible. And if I were a developer, if I were starting a company, I would be thinking about the kinds of things that are just on the edge of what the AI can do today and building for those use cases where they like don't quite work today because 3 or 6 months from now, they're going to work super well and you're going to be ahead of everybody else.
Yeah. Do you have guidance for the developers here? Like when should they use O1 versus other models? And for example, you mentioned coding. Is coding a good O1 task or no?
Yeah, actually, that is one thing that we found. O1 is a very good programmer, especially when you have hard things. You know, if you're just like, hey, I need you to like write me a Python function to like sort this list, it's, you know, fine. Every model can do that. But when you have really tough programming questions that require you to reason through and make a bunch of trade-offs, that's where O1 really specializes. I think in general, though, there's something about, in a world that's evolving this quickly, trying to think about the kinds of things that the AI can't quite do. And when you build towards those, you know that you're building a product that doesn't quite work, but in 3 months, it's going to work, and that's going to be an awesome thing. And Sam has said a few times, if you're building something and you're afraid of OpenAI's or anybody else's next model launch, then you may not be building the right thing. If you're just kind of like covering in gaps and where the model doesn't quite get something right, then that's not as good of a place to be. If you're building something, though, where you can't wait for the next big model launch because it's going to make whatever you're doing 10 times better, that's an awesome place to be because it means you're pushing the frontier of intelligence. You're pushing on like new product areas that weren't possible before and are just becoming possible. And I think that's the most interesting set of things.
Yeah, that's a great heuristic. So when will the rest of the world catch up on O1?
I mean, tomorrow, next year, 12 months from now, I mean, that's the fun part of this industry is there's so much to be discovered. All of the labs are doing really great foundational work, and sometimes with slightly different focus areas. So they'll have like, one will be ahead in one place, one will be ahead in another place. I think that's like an exciting part of the world. There's a lot of competition. You have to be at your best. You got to work really quickly. Our job is, I assume that at some point other labs will figure out, the techniques, the ways that we built O1. Some of this stuff diffuses over time. And it's our job that by the time they do that, we're already 3 steps ahead. And we really do feel like with O1 in particular, the techniques, we're kind of and I mentioned it's a different paradigm of scaling. Like it's not this massive pre-training run, it's inference time scaling. We think we're at the GPT-2 sort of phase of that, and we see a lot of low-hanging fruit that we can go pluck to make these models better very quickly. So by the time people do catch up, we're going to try and be 3 more steps ahead.
Yeah, and this trend of introducing additional inference time compute or complexity, that's something that I think is very relevant for this audience, especially if you're thinking about the serving systems to power that. It's going to get a lot more complex.
Yeah, absolutely.
Now, let's talk a little bit about consumer products. So you contributed to building some of the world's most successful consumer products, right? Twitter, Instagram, and others. Ultimately, social media figured out how to monetize through ads. Right? So how does consumer-facing AI ultimately get monetized? Right? Is it $20 per month subscriptions? Is it something else?
It's a really interesting question, and I'll just say up front, I don't think we have all the answers right now. We certainly have no current plans to do anything with advertising. But especially as the models get smarter, imagine, we've heard examples of senior lawyers at law firms who said, I just had O1 write a legal brief for me. That would have taken a $1,000 an hour associate 6 hours, and it did it in 5 minutes. What does it mean when you can suddenly do $8,000 of work in 5 minutes for like $3 of API credits? So I don't think we know all the answers. Yeah. And also, like, part of our mission is to bring this to everybody. There are lots of places in the world, and we have a free product, and we always will. We believe in it deeply, and we really try and make AI cheaper and cheaper and cheaper so that we can offer more in that free product. But there are also going to be reasons that you want the $20 a month subscription, and there are a lot of people in the world that can't pay $20 a month. So how do we, on the one end, sort of share in the value that we create if we're taking something that used to cost $8,000 and doing it in 5 minutes for a small fraction of that, and also try and bring AI to the rest of the world that may or may not be able to pay. Like, it's an open question.
I mean, do you think, where will this land? Will it end up being $3 worth of API tokens, or do you think you'll be able to charge something closer to $8,000?
I have no idea. I think the world is going to change, and if it becomes possible to do these things for $3, you also can't go and charge $5,000 for them for very long, because someone is going to come along and charge, like, very quickly these things end up at around the actual cost of production. So it's just a different world, and I mean, we are kind of all of us in this room creating that world together, and we all get a chance to kind of shape it.
When you're planning the ChatGPT roadmap, do you have certain product analogies that you find helpful? Perhaps thinking like, oh, this is kind of like search, or kind of like a messenger app, or anything like that?
Yeah, it's funny. Actually, the best analogy I've at least personally found is trying to think of the systems almost like another human. And I'll give you a couple examples maybe. With O1, it's gonna think for a while, right? So you have 30 seconds or 60 seconds maybe where someone's asked a question, it's thinking through the answer. So what do we do in the UI while that's happening? If I ask you a hard question that you don't know the answer to, most people don't like just start blurting out chain of thought, right? And like just start talking nonstop as they think through the problem. And most people also don't just like go mute and turn around and stare off into space for 60 seconds. Like you kind of give periodic updates. You're like, I'm thinking it might be this. Give me a sec. Like you kind of give periodic updates, and so that's where we landed with what the actual product does. Also, with like voice mode, there are different ways. You realize how different it actually is when you're speaking with someone versus when you're writing. I don't know if you've ever like written a talk for yourself to give and then said the words that you wrote. It feels super stilted, at least it does for me. And I have to like change the manner in which I write in order to make it feel natural if I'm going to speak it. And we had the same kind of challenge with getting advanced voice mode right. We had times as we were building it where it would always follow up with like you'd ask it a question, it would give you an answer, and then it would follow on with another question and kind of feel like it was needy a little bit, like it was trying to extend the conversation. So there are these funny ways in which just trying to be like, okay, what would I want a human to do in this scenario gives you some guideline for how the AI should behave. Because it's funny, in these, the behavior of the model itself is actually a product unto itself. The sort of personality and other things. So we have PMs and engineers who are thinking about how we shape the personality of the model.
Yeah, and that's actually a really interesting insight. It's not obvious, but written English and spoken English are just different languages.
Yeah. I mean, yeah, at least for me, I would sound super stilted. And by the way, if you took this and just digitized it and read it, I'd probably sound like a complete idiot.
So UX is super important here. You're talking about a lot of UX breakthroughs that you guys made. And of course, the chat interface was a massive UX breakthrough. Voice mode is another one. Are there other ones we haven't, or you haven't rolled out yet or accomplished yet, but you think are important?
Well, I think it's really clear that model responses need to become richer. And right now, it's a lot of text back and forth. One of the things that we believe and are building towards is that you should be able to interact with these, with our models in every way that you interact with another human being. So, I type a lot to people. I've typed a bunch to you this morning. We've interacted that way, and of course, that's how most people interact with ChatGPT today. But I also speak, I also see, and we want you to be able to speak to the model and have it speak back. We want you to be able to hold up your phone and show the model what you're seeing and ask it questions about what's going on in real life. We've talked about Sora, where the model is generating video on the fly. So all of these things need to be just like natural and completely integrated. The model responses, I think, will be much richer. So you won't just get text back, you'll get multimedia, you'll be able to act on that, there'll be a lot more going on there. And that all I think is pretty clear. It'll be interesting to see how long the chat interface actually holds. As we shift towards more agentic behaviors and you're asking the model to do things over a longer period of time and it's checking back in with you, I actually think chat may still hold as sort of, it'll need to evolve, but as a rough paradigm, it may still hold. Because I guess, as like a model of how we interact as humans, chat and conversation in general is actually how we collaborate. And so if you think of yourself as collaborating with an increasingly intelligent AI and chat as just a model for conversation, it scales with humans today. So we'll see. It's one of the fun things about getting to build in this space.
On a different topic, people have expressed concerns about models being too left-leaning or right-leaning or politically correct. If you think about values, is that something that the research team handles and the values are just built into the model during training or post-training? Or is that something that happens at the products layer around the model?
Yeah, these are really interesting questions. And by the way, I doubt that if we polled everybody in the room, we would have agreement on it. There are some questions, if you're asking it about politics, things that people are 50-50 on, obviously the model shouldn't take a stance there. What if you ask it about, is the Earth flat? There's like 99+% agreement on that one, but not 100. So should the model take a stance? What if it's 80-20? These are tough questions. So what we've done is we've published a model spec. And we've given a ton of examples and basically said, this is the spec that we are instructing our model to follow. And it's out there. It's in natural language. You can go read it. We put it out for open comment. We take comments on it all the time. And so if the model is not behaving in a natural way, there's two reasons that can be, if you don't like it, there's two reasons. One, it's not following the spec, or two, you disagree with the spec. And in the first case, if it's just not following the spec, then that's effectively a bug and we should go fix it. If it's not following this, or if the spec is just not what you would like it to be, then that's a debate that we can have. But at least we have a published spec that we can go, as a society, kind of argue about. So that's the approach we've taken. I think so far it's been pretty, we have great debates around the spec, and the spec has to evolve as the model gets new capabilities. But so far that's held. But it's better to have a document that you can have a debate about versus just being like, oh, I got this answer and I didn't like it, go fix it, OpenAI. So that's the approach we've tried to take.
I agree that's a great approach. For people building products on top of the model, a lot of us here are building not just models, but really building systems around your models.
Yeah.
What is the right, if I'm thinking about safety and things like that, and safety, of course, can mean many different things, but if I'm thinking about safety, what is the right unit of analysis? Is it the model, or is it the system and product around the model?
Our belief is that it's both, from sort of a defense in depth approach. There are certain things that we want the model to know, never to do, never to answer. And then there are certain things that I think will change based on the context of the application that it's in. So for ChatGPT, we're going to take a certain set of points of view. Whereas if you're talking about the API, there's more freedom for you to take a different point of view. If you're a nuclear fusion scientist, there are certain questions that we don't want the model to be able to answer in ChatGPT, but probably makes sense for you to be able to talk about. So there are places where we're just going to take a stand and say the model shouldn't do this, it's illegal, or it's fundamentally not something that we want a product that we build to be able to do. And then there are places where it's going to be much more context dependent, and we want to allow for that.
Yeah, that's fascinating. I'm curious, when writing this spec, coming up with this spec, what skill sets and the people contributing to this do you find are most important for doing a good job?
So we actually employ, I mean, in thinking about model behavior more generally, we actually employ a bunch of writers that can help the model sort of express itself and get its emotions right, if you will. It's also, so when I was at Twitter back in the early days, like 100 years ago, Ev said something that has stuck with me, which kind of carries through to OpenAI today. But his thing was, no matter how many smart people you have within your walls, there are way more smart people outside your walls. And that's so true about any sort of societal change sort of issue. And the way that's relevant at OpenAI, we believe in this philosophy of iterative deployment. So when it comes to new technology and all of the challenging societal aspects that come with it, from safety all the way to much more mundane things, our belief is that getting the models out there and progressively exposing them to broader groups of people is actually the way that we make them safe. It's actually the way that we slowly drive positive change in the world. And so that's kind of the approach that we take here. It's why the model spec is public, it's out there, and we solicit comments on it and improve it with the feedback of people from all around the world, not just with the feedback from a bunch of people at OpenAI.
That makes sense. And actually, we've benefited a lot with Ray from the broad open source community and contributions from so many different companies.
Yeah, absolutely.
Maybe to close, can you share a little bit about what you think the future will look like and what you're excited for?
I think it's going to be fun. So I gave the example of ChatGPT acting as a translator for me, which was kind of mind-blowing as an experience. I'm also excited about things like when every kid growing up has a personalized tutor. I'm actually sort of surprised that doesn't exist today. Khan Academy is doing interesting things there, but nothing seems to have taken off. Like, I bet most of our kids in the audience are not yet doing that, let alone people all over the world that are maybe less sort of AI attuned. But that feels like a thing that's almost inevitable. And when you look at the outcomes that kids have when they get personalized tutoring versus going through school, I mean, it's a multiple.
Actually, can I ask you that? Does that fall in the category of something where there's room to build a lot of value on top of OpenAI's models, or something where the next model is just kind of going to render my work obsolete?
Oh, I think there's a massive amount of room. I think in some sense we're approaching this point, or maybe we're already at this point, where we're less intelligence limited than we are eval limited. Like, it's more, the model has the intelligence to do all kinds of things, and it's really more about applying it to very specific use cases, teaching it things that it may not know right off the bat, but can learn, applying data sets that are not public. You have private data that's gained through years of doing some business, and like making the model really good at specific things. There's no way that we are going to do most of those things. It's why we partnered with Khan Academy, for example. It's why we build an API. We want developers like you all to go build a bunch of these amazing things, because the faster we can disseminate AI out into the world, the faster we believe the world becomes a better place. So I'm super excited for that, and I think the models are going to get good at a really fast clip. And that means that we all have a huge amount of opportunity ahead.
Yeah, that point about being eval limited is really insightful. Kevin, thank you so much for sharing your insight. It's been a pleasure chatting with you.
Yeah, thanks so much for having me.
Thank you. All right. Thank you all so much. This is the end of our today's keynote section. Please enjoy the rest of the conference, and thank you all so much for being here.